Today, I'm going to talk about springs and how they can customize the feeling of your mechanical keyboard. To start at the very basics, a switch is made of 5 different parts: the bottom housing, contact leaves, the spring, the stem, and then the top housing. As you push down on the switch, you're compressing the springs, then the legs of the stem makes contact with the leaves in the bottom housing to activate the switch, and then when you let go, the spring uncompresses to bring the stem back up to fully reset the switch. Springs are usually listed in bottom out force, or how much force it'll take to fully push down on the spring. For example, a spring rated at 60 grams will be easier to push down than a spring rated at 70 grams. But why would you want to swap out the spring in the switch when you can just buy a switch that comes with a lighter spring? Well, for one, the included spring may not be that great. On some stock switches, the spring can have a lot of spring crunching noises or spring pinging noises when you activate the switch. You can loop the spring to mostly fix this, but it can be better to just replace the spring outright. Second, perhaps you like everything about the switch except for the spring itself. For example, let's take a look at Gateron black inks. The housing of Gateron black inks are made out of some kind of special plastic, giving it its own unique sound signature versus other switches. However, the 70-gram springs included with them are a bit too heavy for me, so I'm going to swap out these springs with something else. Lastly, there's more to springs than just the weight. I'll be going over 3 different types of springs: linear, slow, and progressive. Here's a fake graph I made to represent these 3 different springs. On the x-axis, we have the travel distance for the switch, and on the y-axis, we have the force required to push down on the switch. Let's assume that all of these springs bottom out at 65 grams and that the swing actuates at 2 millimeters. You can see that the red line and the green line looks pretty similar since the force required is linear. However, they will feel different. The red line has a higher slope than the green line, which means the force required to push down would change at a faster rate than the green line over time. This results in the green spring having a more consistent feeling than the red spring. The green spring also starts at a higher force than the red spring, so it will take more initial force to start pushing down on the spring. Now let's take a look at the black line here, representing a progressive spring. A progressive spring has a non-linear increase in force. This makes a switch feel lighter before actuation, then ramps up as the switch starts to bottom out. This can help prevent you from bottoming out on a switch if that's something you're looking to do. Next, let's take a look at actual force curves by looking at these graphs on Gateron yellows and Gateron blacks. Gateron yellows comes with a slow curved spring, while Gateron blacks have a standard spring. These 2 springs actually have different bottom out forces, so looking at the graph won't tell us much about the differences between these 2 springs, other than the Gateron blacks coming with a stiffer spring. However, we can calculate the slope of these 2 springs by digging into the table data. The equation for slope is y2 minus y1 over x2 minus x1. I calculate the slope of the Gateron yellow springs to be 6.43 grams and the slope of the Gateron black spring to be 8.07 grams. So yes, over time, you'll feel a smaller increase in force with the Gateron yellows, the slow curve springs. In this next section, I will be referencing a post by Walkerstop on Keebtalk.com. You can find the link to the post in the descriptions below. If an object applies a force to a spring, then the spring applies an equal and opposite force to the object. Hooke's law tells us the force a spring exerts on the object with this equation. F equals kx, with F being force, k being the spring constant, or how stiff the spring is, and with x being how far the spring has been compressed, or in our case, how far we have pushed down on the switch. However, when a spring is in a switch, the spring itself can already be compressed, which affects the stiffness of the spring. Therefore, you can think of the equation as F equals k of x plus p, where this new p is the preload, or how much the spring is already compressed before pressing down on the switch. This is important because slow curve springs, or the green line in the fake graph that I made, are longer than a normal spring. This results in more preload, which means the spring is stiffer at the start, which means less change in force required to push down on the switch over time. This results in a more consistent feeling as you push down on the switch. The density of the coils in the spring also plays a factor in the spring's stiffness. The less coils that the spring has, the stiffer it will be. And likewise, the more coils that a spring has, the less stiff that it will be. This is how progressive springs are made. Therefore, in our equation, the K, or the spring stiffness, is not a constant. This is accomplished by having a difference in the density of the coils along the spring itself. As you press down on the switch, the tighter coils compresses first because it's the least stiff part of the spring. As you continue pressing down, the stiffer parts of the spring starts to compress, or where the coils are not as dense. A common question I see a lot about progressive springs are, does the orientation of the spring matters in the switch? I've heard people say that it does and that the denser side of the spring needs to be on top, but I've also heard people say it doesn't matter. Personally, I can't tell the difference if the denser side of the spring is at the top or the bottom, and this force curve posted by Nebulant in the Key Company Discord confirms this. You can see that both lines are basically the same within margin of error. Let's shift gears to aftermarket springs that you can buy. I have springs by TX Keyboards, Sprit, and Thic Thoc. With TX, I have both their 14mm 65-gram spring and their 16mm 65-gram spring. The 14mm is a standard spring, and the 16mm is their slow curve spring. As for Sprit, I have their 63.5-gram slow springs and 63.5 complex springs. I wasn't able to get Sprit's 65-gram slow springs to compare with TX's 65-gram 16mm springs, but a difference of 1.5 grams basically doesn't matter. And the complex springs are their special progressive springs. Lastly, I have Thic Thoc's 65-gram deliciously linear spring and their 68-gram magically progressive springs. On my test board, I have linear Gateron yellows and tactile navy switches to try out all of these springs on, and these are my impressions. Let's start with the navies, the tactile switch. I didn't like the complex or progressive springs on them. Since the pressure need to push down the switch is so light at the very top, it really de-emphasized the tactile feeling of the switch, especially on the navies where the bump is very close to the top. Both the slow springs by Sprit and TX emphasized the tactile bump by a little bit, and I thought that was really nice. Shifting gears to the Gateron yellows. Since the Gateron yellows come with stock slow curve springs, the TX 14mm spring made the switch feel a little bit lighter at the very top. Both the slow springs by Sprit and TX felt very similar to the stock Gateron yellow spring, but I would say they are a bit heavier. Both the complex and progressive springs by Sprit and Thic Thoc made the linear switch feel a bit more interesting with the lighter weight at the very top. Lastly, I want to talk about the 65-gram spring by Thic Thoc. They measure at around 15.25 mm, about the same as a stock Gateron yellow spring, but about 1 mm shorter than the Sprit and TX slow curve springs. From this, you can say that the Thic Thoc linear spring are pretty similar to a slow curve spring. Even so, when compared to the TX 14mm spring, the Thic Thoc spring felt less stiff throughout the whole entire switch, even though both are labeled at 65 grams. I really wish I had a machine to create a force curve out of all of these springs, because feeling them all by hand is really messing with my mind. Out of all of the springs here, this is how I will rate them right now. My number one choice is the Thic Thoc 65-gram linear spring. My second choice is the Sprit 63.5-gram slow spring. And at number 3 is the Thic Thoc 68-gram magically progressive spring. The Thic Thoc and Sprit spring felt very, very similar to me, but for some reason I just like the Thic Thoc spring a little bit better. I can't really explain why. And I thought the 68-gram progressive spring just made the linear switch feel a bit more interesting versus the other springs. I still don't like them on tactile switches, but I mostly use linear switches anyways. To be honest, if you're not very particular about the feeling of your keyboard, then don't worry about all of these different types of springs. It should be the last thing that you think about when customizing your keyboard. When I'm gaming or typing really fast, then these different springs don't really matter to me all that much. If the stock spring that comes with a switch isn't very good, then just pick any aftermarket spring that's easiest for you to get at your desired weight and then call it a day. Alright, that's it for me today. Please like the video if you found it interesting and subscribe to stay updated on my future content. Until next time.